After watching this video, you'll be able to understand how metal ores can be extracted using carbon. You'll also be able to explain the steps involved in extracting a metal from its ore. You'll be able to include a word equation and give a balanced chemical equation for an example. Rocks that contain metals are called metal ores. They are a very valuable resource, so finding ways to extract or remove the metals from the rock to get a pure sample is very important. As the metals are mostly found as compounds, a chemical reaction is needed to separate the metal from the other substances. Some very unreactive metals, such as silver, gold, and platinum, are found pure. These samples do not tend to combine to make compounds, and so are easier for us to collect. However, other metals are found combined. For example, the picture shows galena. Galena is an ore of lead. Galena is mainly made up of lead sulfide. Lead chemically combined with sulfide. There are two main stages in obtaining a pure sample of a metal, and mining is the first stage. For all ore samples, mining is very similar. The rocks that contain the metal ores must be obtained from underground. Large machinery is used to dig the rock out in large areas called quarries. Sometimes drills have to dig deep underground to get to particular valuable ore sites. Once taken from the rocks, the ore samples need to be physically separated from other waste rock. This will give a concentrated sample of ore. An ore must contain enough of the metal compound to make it worthwhile extracting in terms of costs. Extracting the metal from the ore requires a chemical reaction, and the principles of the reactivity series are used. You will notice the addition of a non-metal, carbon. This is because it would not be sensible to use one metal to extract another, as all metals are valuable resources. Carbon is readily available as coal or charcoal and is also very cheap. You will remember that a more reactive substance can displace a less reactive substance from its compounds. That is exactly what happens when carbon is reacted with the compounds formed by the metals below it in the reactivity series. For example, the ore malachite contains the compound copper carbonate. When it is heated, it decomposes to make copper oxide. This can then be reacted with carbon to extract the copper. This reaction does not happen at room temperature and requires very strong heating to enable the reaction to start. In addition, it must happen away from a source of oxygen, otherwise the hot metal will simply react with the oxygen in the air and reform the metal oxide. In the laboratory, this can be investigated by mixing the copper compound with charcoal and covering it with a layer of coal to keep oxygen out, or by using a crucible lid. On an industrial scale, this would happen inside a blast furnace. A blast furnace reaches a very high temperature, around 1500 degrees centigrade. Coke, which is a pure sample of carbon, is used to extract metals such as copper and iron. When metals are extracted, it is a type of decomposition reaction. When the ore contains the metal oxide, we use a reduction reaction to extract the metal. The compound containing the metal is reduced or broken down to release the metal and loses oxygen. In these examples, carbon acts as a reducing agent. You should now be confident enough to tackle these questions. Why not have a go at them and type your answers in the comment section below? To stretch yourself even further, you can complete this task to show that you understand how metal ores, like hematite, which is an ore of iron, mainly iron oxide, can be extracted using carbon. Explain the steps involved in extracting the metal iron from the ore hematite. In your explanation of the steps involved in extracting the metal iron from the ore hematite, it would be very useful for you to be able to include a word equation. If you really wanted to stretch and challenge yourself, include a balanced chemical equation. I hope you've enjoyed this video, learned a lot from it, and wish you the best of luck in your exams. Take care. Bye.